Hello everyone, welcome to Wallah. So we are going to discuss ninth lecture of transmission line. In this lectures we are going to discuss VSWR. So today we will start VSWR and tomorrow we will end up VSWR. So this is the 2 hours lectures. So today I will start and tomorrow we will end up. And then after we will discuss some questions regarding VSWR and impedance. So today is our topic VSWR. In previous class what we have studied? We have studied impedance. And second we have studied reflection coefficient. And in this lectures we will cover the topic. VSWR, voltage standing wave ratio. So we are going to discuss the topic. So we are going to discuss the topic voltage standing wave ratio. What is a standing wave ratio? First of all, what is a standing wave? Then we will discuss standing wave ratio. First of all, we have discussed standing wave. Then we will discuss standing wave ratio. This is a bucket of water. This is a bucket, and in this bucket, if we throw one stone, in this bucket, if we throw one stone, then their wave is generated. There will be a wave which is generated, and the wave will travel towards the end of the bucket. So when you throw a stone in middle of the bucket, then there is a wave towards the end of the bucket, and the wave is reflected back, and it will form a standing wave. The wave will reflected back, and it will form a standing wave. So if you throw a stone in a water, then a wave will be created, and the wave will be bounced back from the side of the river or side of the bucket, and there is a reflected wave. So there is a traveling wave, there is a reflected wave, and there is a standing wave. So when traveling wave and reflected wave are sum up, then it will give a standing wave. So a standing wave will be formed when forward wave and reflected wave are added. So what is a standing wave? A standing wave is sum of forward wave and reflected wave. Forward wave and reflected wave. It is sum of forward wave and reflected wave. Okay. Then we have what is forward wave voltage equation. You don't have to remember this, only for study purpose, only for understanding purpose I am going to write this formula. So forward voltage wave equation is V naught upon 2 ZL, ZL minus Z naught, e to the power minus ZL plus Z naught, e to the power minus gamma Z plus gamma Z plus gamma X and plus ZL minus Z naught, e to the power minus gamma X. So this is our forward wave, and second is our reverse wave, reflected wave. So this is our reflected wave or reverse wave, ZL minus Z naught, e to the power minus gamma Z X. Yes. In case of lossless, this gamma will be replaced by J beta. In case of lossless, this gamma will be replaced by J beta. So it will be VL by 2 ZL, VL by 2 ZL VL by 2 ZL ZL plus Z naught, e to the power J beta X. In case of lossless transmission line, the reflected wave will be written as ZL minus Z naught, e to the power minus J beta X. Yes, sir. And this is known as forward wave. This is forward wave. And second one is reflected wave. And sum of forward wave plus reflected wave is standing wave. Sum of forward wave plus reflected wave is standing wave. Sum of forward wave plus reflected wave is standing wave. So this is a standing wave. Okay, this is our standing wave. Then after we will add these two terms. First one is forward wave and second one is reflected wave, and then we will get the standing wave. So we will add this two term, VL upon 2 ZL, ZL plus Z naught, e to the power J beta X, and VL upon 2 ZL, ZL minus Z naught, ZL minus Z naught, e to the power minus J beta X. Okay, then I will take this term common. What we will get when I will take this term common? So we will get VL upon 2 ZL, ZL plus Z naught, e to the power J beta X. What we will get? We will get 1 plus ZL minus Z naught divided by ZL plus Z naught, e to the power minus J2 beta X, e to the power J minus J2 beta X. This one is forward wave. Yes, sir. So Vx will be equal to VFX 1 plus ZL minus Z naught, ZL plus Z naught is gamma L, e to the power minus J2 beta X. Okay, then VFX and 1 plus mod gamma L, e to the power minus J2 beta X minus theta gamma. Okay, we have derived this. Magnitude of gamma L is written as mod gamma e to the power J theta gamma. E to the power J theta gamma, if I will take minus J comma, it will be minus theta gamma. So it will be written as 2 beta X e to the power minus theta gamma. Then there is a two condition that it will have maxima and minima. Then there is a two condition, it will have maxima and minima. what is the condition? If I will ask what is maximum value, so you will say maximum value will be VFX 1 plus, and the value should be this e to the power j beta x should be 1. If it is 1, then the maximum value will be 1 plus mod gamma L. And if I will ask what is the minimum value, so you will say the minimum value should be VFX 1 minus mod gamma L. So here in case of maxima, the e to the power minus j 2 beta x minus 2 beta x should be in case of maxima should be 1, and if I will ask what is the value for this one, so in this case 2 beta x max minus theta gamma should be equal to -1. So in this case we have minima. So for minimum it will be -1, for maximum it will be +1. So this is the condition for -1 and +1. There is a ratio for maxima and minima, so the ratio will is known as a standing wave ratio. So these two things you have to remember. This is the point you have to understand: what is maximum value, what is minimum value, when it is happen maximum and when it is happen minimum. Okay, so this one is gamma L. I will describe this also. If you don't understand John Wick, I will describe this. Okay, so this is our 1 plus mod gamma and 1 minus mod gamma. So what is gamma L? E to the power minus j 2 beta x. So gamma L e to the power j minus j 2 beta x means j 2 beta x means you have to write magnitude of gamma L e to the power j theta gamma. I taught you in the previous class e to the power j theta gamma. This gamma L will be which part? This gamma L has magnitude and angle both. So we can write this minus j 2 beta x. So it will be written like this: magnitude of gamma L minus j 2 beta x minus theta gamma, and this value will be positive and this value should be negative. So there is two types of values. One value is this one is +1 and second one is -1. So I have written gamma is something magnitude of gamma L e to the power j 2 beta x minus theta gamma. You will ask how it is +1, how it will be -1. I will tell you after 2 to 3 minutes how it will be +1, how it will be -1. So this one is the value. So you can understand only by somehow it is +1. So if it is +1, it will be magnitude of 1 plus gamma L, and if this value is -1, so it will be magnitude of minus gamma L. So this one is maximum value, this one is minimum value. So we got maximum and minimum value. So maximum and minimum value we got. So what is, first of all, what is a standing wave ratio? A standing wave ratio is nothing, maximum upon minimum. First of all, I will define a standing wave ratio, then I will define the how it is getting maximum and minimum value. So standing wave ratio is maximum upon minimum, maximum upon minimum, maximum upon minimum. So there will be current maximum, there will be voltage maximum, and this should be known as a standing wave ratio. A standing wave ratio. Yes, sir. Then we have VSWR. VSWR is nothing but voltage standing wave ratio. VSWR is nothing but voltage standing wave ratio, and voltage standing wave ratio, so it will be Vmax upon Vmin. And there will be current standing wave ratio. There will be current standing wave ratio. In this case, what it will be? Current standing wave ratio, that means I max upon I min, I max upon I min. In case of electric field standing wave ratio, in this case in 2024 they have asked electric field standing wave ratio. So this is E max upon E min, E max upon E min, and there is magnetic field standing wave ratio, that means H max upon H min, H max upon H min. So this is the formula for standing wave ratio. It can be voltage, it can be current, it can be electric field, it can be magnetic field. The formula for all of them is, the formula for all of them is 1 plus magnitude of gamma, 1 minus magnitude of gamma. So formula for all of them is 1 plus magnitude of gamma, 1 minus magnitude of gamma. So you can see it here. If Vmax upon Vmin I will take, so Vmax upon Vmin, this one will be cancelled out and we will get 1 plus magnitude of gamma L, 1 minus magnitude of gamma L. This is for which part? Lossless, because I have taken e to the power j beta x. So for lossless, 1 plus magnitude of gamma L, 1 minus magnitude of gamma L. So this is the formula for which part? This is the formula for SWR. So we can understand the value. The SWR should be, it may be voltage standing wave ratio, it may be current standing wave ratio, it may be electric field standing wave ratio, it may be magnetic field standing wave ratio, anything. The formulas will be same, 1 plus mod gamma, 1 minus mod gamma, and it will be standing wave ratio formula. So we have understand standing wave ratio formula. We have understand standing wave ratio formula. Then we have the term that there is a transmission line. Yes sir, this is the transmission line. I will teach you how it is plus 1 and how it is minus 1. This is the transmission line. Yes sir, this is the transmission line. Yes sir. So what will happen? This is the value. Yes sir, theta gamma. This is ZL J. Yes sir. So here gamma is mod gamma L, and it will be magnitude of gamma L e to the power j theta gamma. Magnitude of gamma L e to the power j theta gamma. If I will travel some distance from this load, so what we will get? We will get gamma x. Gamma x is magnitude of gamma L e to the power minus j 2 beta x. So it will be magnitude of gamma L e to the power minus j 2 beta x minus theta gamma, So what we are getting? We are getting something that the distance from x will changing. The distance x will change. How it will be changed? If you travel from load to source, from load to source, if you travel, you will get your distance will change. So if distance is changing, the value of 2 beta x will also be changing. So the value of x will also change. Here x will be lambda by 4, here x will be lambda by 2, here 3 lambda by 4, here lambda. So if you increase the x value of x, the 2 beta x value will also change, and the 2 beta x value will change, then e to the power minus j 2 beta x value will also change, and e to the power minus j 2 beta x value will change. So it will give plus 1 and minus 1. It will give plus 1 and minus 1. So plus 1 and minus 1 will be calculated according to by thinking that the magnitude, that the value of x will change and that value will change. So our magnitude of e to the power j theta gamma x will also change. So at some distance, at x is equal to x max, e to the power minus j 2 beta x, e to the power j 2 beta x, the value will be plus 1. The value will be plus 1. At x max, voltage is maximum. At x max, voltage is maximum, and at x min, the x min the x min, at which the voltage will become, at x min the voltage will become minimum, the voltage will become minimum. So e to the power j2 beta x minimum minus theta gamma is equal to minus 1, minus theta gamma is equal to minus 1. Yes sir. So we have V max, we have V min, we have e to the power 2 beta x max minus theta gamma, we have e to the power minus j2 beta x min minus theta gamma. So when the value of x is such like that, the value of x is like that, the value of e to the power j2 beta x minus theta gamma is plus 1, and the value of x is taken like that, the e to the power j2 beta x is minus 1. Then we will understand when e to the power j theta is plus 1, e to the power minus j theta is minus 1. So we will have to understand this thing also. So what we will do, we will go for some analysis. We will go for some analysis. What is the analysis here? Then we will go for some analysis. What is e to the power minus j theta? So you will say e to the power minus j theta is e to the power cos theta minus j sin theta. Then I will ask what is e to the power j pi? So you will say e to the power j pi is cos pi minus j sin pi. Cos pi is minus 1, so it will be minus 1. E to the power minus j2 pi, e to the power minus j2 pi is cos 2 pi minus j sin 2 pi. Cos 2 pi minus j sin 2 pi is plus 1, and e to the power minus j3 pi is cos 3 pi and minus j sin 3 pi. Cos 3 pi is minus 1. Then e to the power minus j4 pi is cos 4 pi and minus j sin 4 pi. So it will be plus 1. So like that you can understand, if it is pi it will be minus 1, if it is 2 pi it will be plus 1, if it is 3 pi it will be minus 1, if it is 4 pi it will be plus 1. So it will be plus 1 when 2 beta x max minus theta gamma is pi 2 pi, 4 pi, 6 pi, and it is minus 1 when 2 beta x min is pi, 3 pi, 5 pi, 7 pi. So we can say that e to the power minus j 2n pi, that means even multiple, it will be plus 1, and e to the power minus j 2n plus 1 pi, it will be minus 1. So we can use this point. Okay, we can go through this point. 1 minute, I will come back. Okay, then we can go through the point e to the power minus j 2 beta x max minus theta gamma is equal to plus 1. That means e to the power 2 beta x max minus theta gamma is equal to e to the power minus j and 2n pi. So we can conclude 2 beta x max minus theta gamma is equal to 2n pi. Then 2 beta x max is equal to 2n pi plus theta gamma, 2n pi plus theta gamma. Then 2 beta is equal to 4 pi by lambda x max. 2 beta is 2 pi by lambda, beta is 2 pi by lambda, so 2 beta is 4 pi by lambda x max 2n pi plus theta gamma. So x max will be equal to 2n pi plus theta gamma into lambda divided by 4 pi. So this is the formula for x max. This is the formula for x max. Then we have x min. We have x min. So e to the power 2 beta x min minus theta gamma is equal to -1. So we can write it e to the power minus j 2 beta x min, it is -1, so it should be odd multiple of pi. It should be odd multiple of pi, 2n pi. And if it is 2n pi, so 2 beta x min minus theta gamma is equal to odd multiple of n pi. So odd multiple of pi. Then we have x min is equal to odd multiple of n pi, 2n plus 1 pi minus plus theta gamma into lambda divided by 4 pi. So this is the formula for x min. So you can remember the formula for V max. You can remember the formula for V min. You can remember the formula for x max, and you will remember the formula for x min. Then you can solve the very good problem. You can solve the problem of VSWR. So what we have derived, this derivation is not that much important. The point is important, that what is the formula for V max, what is the formula for V min, what is the formula for VSWR, what is the formula for x max, and what is the formula for x min. If you know this point, then you can analyze the topic very far easily. Then we will go through some mathematical analysis regarding VSWR. What are the mathematical analysis? We will take the different value of ZL and plot the VSWR and analyze the VSWR. So we are going to analyze the VSWR, and then after this, according to this analysis, we will write the summary, and that summary point, so tomorrow we will write the summary. Today we will analyze the VSWR, and then after analysis, what we will do? We will do the question discussion. The VSWR is our major topic, so we are going to discuss in a very good way. So what will be the point here? First point is, what are the first point? First point is our ZL will be, I will take only real value of ZL. I am not taking the imaginary or complex value of ZL. I will analyze for complex value of ZL after in summary, but for analysis I will do only for real value of ZL. So I am taking only a real value of ZL. So the ZL will be maybe 0. The ZL may be 0 because the real value of ZL, minimum value will be 0. Maximum value will be infinite. And there is some chance that ZL is less than Z0. That means Z0 is 50 ohm and ZL is less than 50 ohm. Here there is a chance that ZL is equal to Z0. Yes sir. And here there is a chance where ZL is greater than Z0. So there is a major chance that less than Z0, greater than Z0, equal to Z0, or infinity. So there is 5 cases for ZL. First case is 0, less than Z0, equal to Z0, greater than Z0, and infinity. So I will go for first case. Case 1. Case 1 is ZL is equal to 0. ZL is 0, that means short circuit at load. Short circuit at load. Short circuit at load. Okay. Then what we will do? Then first of all, I will calculate gamma L. I will calculate gamma L. Gamma L is equal to ZL minus Z0, ZL plus Z0. what is the value of gamma L? -1, because ZL is 0, so it will be -1. So it will be written as e to the power j pi. So magnitude of gamma L is 1 and theta gamma is -1. Yes sir, theta gamma is pi. So we have calculated magnitude of gamma L and we have calculated theta pi. Then second point is we will calculate maximum value. So Vmax will be equal to 1 plus Vmax is equal to Vf into 1 plus magnitude of gamma L. So it will be 2 Vf and Vmin is equal to Vf into 1 minus mod gamma L. So it will be 0. So maximum value is 2 Vf, minimum value is 0. Then we will go for next analysis, that is third point. We will calculate X max. X max formula is, you have to remember the formula for ZL, you have to remember the formula for Vmax, you have to remember the formula for X max. So in summary, we will discuss what we have to remember in VSWR. X max is 2n pi into theta gamma plus theta gamma into lambda divided by 4 pi. So what we have, let theta gamma is pi, so it will be 2n pi plus theta gamma. So theta gamma is pi into lambda by 4 pi. So what we will get? We will get the value of X max. X max is equal to odd multiple of lambda by 4. Odd multiple of lambda by 4. That means X max is equal to lambda by 4, 3 lambda by 4 and 5 lambda by 4, and like that it will be infinite values. So X should be positive. Why? Because X, when X is negative, there is no value. For X negative, nothing is here. For X positive, the load to source. For X positive, load to source, and for X negative, there is nothing. So I will say that lambda by 4, 3 lambda by 4 and 5 lambda by 4. Then the formula for X min is equal to 2n pi plus theta gamma into lambda divided by 4 pi. So 2n plus 1 pi is there for X min. So for X min, I will calculate in different page. So I will calculate it here also. So X min is equal to odd multiple of pi plus theta gamma into lambda divided by 4 pi. So it will be n plus 1 lambda divided by 4, 2. N plus 1 lambda divided by 2. So minimum value of X is 0. When n is -1, it will be 0, lambda by 2, lambda, 3 lambda by 2. So positive value of X is, so minimum value of positive value of X is 0. So first one is 0, lambda by 2, lambda, 3 lambda by 2. For this one, if I will take n is equal to -1, it will be minus lambda by 4 and X should not be negative. So -1 I cannot take here, but here I can take -1 because it will be 0, and 0 we can take because 0 means load. So X is equal to 0 means load. X is equal to lambda by 4 means lambda at a distance lambda by 4 from the load. X is equal to lambda by 2 at a distance lambda by 2 from the load. At a distance lambda by 3 lambda by 4 from the load. At a distance lambda by from the load. So we can measure the distance X from the load. So we can get the location of maxima and minima. So location of maxima is lambda by 4, 3 lambda by 4 and 5 lambda by 4, and the location of minima will be 0, lambda by 2, lambda and 3 lambda by 2. So this is the value of maxima and minima. Then fifth point is you have to draw the diagram. So what is happening here? What will happen here? So let us see what is happening here. So this is our transmission line. Let us assume this is our transmission line. of length L. This is our transmission line of length L. This is our transmission line. There is a axis parallel to this. There is a axis parallel to this. So this is our transmission line, and there is a axis parallel to this. What do you see here? This is x. Yes, sir. This is x. So x will be 0. If x is 0, then what it means? It means at load. So here x is 0. So from this point x is 0, and from this point x is calculated. So you can calculate the value of x also. So this is our location of x. So this x is means at load. At load. At load. That means at load, and at load x is equal to 0, there is minima, and x is equal to lambda by 4, there is maxima. So at load minima, at lambda by 4 maxima. Minimum is 0, maximum is 2 VF. So we can say that from 0 to 2 VF there is the value. From 0 to 2 VF there is the value. So this is the value for 0 to 2 VF. This is our 0, this is our 2 VF, and 2 VF will be at lambda by 4. 2 VF at lambda by 4. So you can understand there is 0 at x is equal to 0. There is 2 VF at lambda by 4. Then there is 0 minima at lambda by 2, maxima at 3 lambda by 4, minima at lambda, maxima at 5 lambda by 4. So minima maxima will occur. Minimum maximum will occur. So minima at lambda by 4. Then we have maximum at lambda by 4. Then minimum at lambda by 2. Then maximum at 3 lambda by 4, and minimum at lambda by 2. So we can say that, we can see here. Yes, sir. So this is lambda by 4. Then we have lambda by 2. Then we have 3 lambda by 4. Then we have lambda. So we can calculate lambda by 4, lambda. Yes, sir. Yes, sir. Yes, sir. So what is happening here? Here at this point minimum, here maximum, then minimum, then maximum, then minimum. So minima is at 0, minima is at lambda by 2, minima is at lambda. Yes, yes, you can see here minima is at 0, lambda by 2, lambda, and maxima is at lambda by 4, 3 lambda by 4, and 5 lambda by 4. So maxima is at lambda by 4, 3 lambda by 4, 5 lambda by 4, like that. So what is the meaning of this one? What is the meaning of this one? So you can draw this diagram. I can draw this diagram so you will understand the meaning of this one. Yes, sir. This is our transmission line. This is our transmission line, which is short circuited. Which is short circuited. Yes, sir. It is short circuited. And this is the graph. This is the graph. This is the graph which you get. Which you are getting. This is the graph which you are getting. Yes, sir. So this is the graph of voltage. This is the graph of voltage which you are getting. So at load, what you are getting? At load, what you are getting? Minimum voltage. At load, what you are at load from load, lambda by 4, you are getting maximum voltage. Then you are getting minimum voltage. Then you are getting maximum voltage. Then you are getting minimum voltage. How? Here short circuit, here open circuit, then short circuit, then open circuit, then short circuit. Short circuit, inductive, open circuit, capacitive, short circuit, inductive, open circuit, capacitive, and short circuit. I taught you in the short circuit, open circuit. So short circuit, voltage minimum. At this point, the image is inverted. That means short circuit become open circuit, then voltage is maximum. Here it will become short circuit, image impedance, so voltage is minimum. Here at lambda 3, lambda 4, it will be inverted. That means short circuit will become open circuit, voltage maximum. Here at lambda, so image impedance, so here short circuit will become voltage means 0. So this is the graph of voltage on the transmission line. This is the graph of voltage on the transmission line. Like that, there is a graph of voltage, there is a graph of current also. There is a graph of current also. What is the graph of current? So this is the graph of current also. So this is the graph of current. Yes, sir. The value of current is also 2Vf. No, it will be 2If. It may be changed, but I am drawing for the graph only, graph purpose only. So this is the graph of current. This is the graph of which part? Current part. This one is the graph of current. Why you are drawing like this, sir? So this is the graph of current. Why you are drawing like this? Because at short circuit voltage is 0. At short circuit current is maximum. So current should be maximum. So this is the graph of for current. This is the graph for current. Which part? Current. Current. And this is the graph for current. It will be 2If. It will be 2If. And this is the graph for voltage. This is the graph for voltage. So voltage standing wave is like this, current standing wave is like this, because at short circuit current is maximum, at open circuit current is minimum, at short circuit current is maximum, at open circuit current is minimum. So when voltage is maximum, current is minimum. So voltage minimum, current maximum, voltage maximum, current minimum, voltage minimum, current maximum, voltage maximum, current minimum, voltage minimum, current maximum. Like that you can draw. Like that you can draw. So this is the point here for VSWR. This is the point here for VSWR. Like that we can draw anything for any graph. So this is the graph for VSWR. Then our case second. Case second. What is the case second? So case second is ZL less than Z0. ZL less than Z0. In this case, gamma L will be. In this case, gamma L will be. So first point is, what is gamma L? Gamma L will be ZL minus Z0, ZL plus Z0. Since it is lesser value, so it is minus K. Let us assume ZL is equal to 50 ohm, 25 ohm, and Z0 is equal to 50 ohm. Z0 is equal to 50 ohm. What you will get? 25 minus 50, 25 plus 50. 25 minus 50 minus 25 divided by 75 minus 1 by 3. So value will be negative and K will be less than 1. So it will be minus 1 by 3. So minus 1 by 3. So value will be negative and K will be less than 1. So K will be less than 1. And value will be negative, that is theta gamma should be pi, because for negative value theta gamma should be pi. So like that you can understand. like that you can understand. So then after second thing is what is Vmax? Vmax is equal to Vf and 1 plus magnitude of gamma L. Magnitude of gamma L is here k, so it will be 1 plus k, and k is less than 1, so 1 plus k is less than 2, so k is less than 1, so 1 plus k is less than 2, so it will be less than 2 Vf. So Vmax is less than 2 Vf. Vf 1 minus magnitude of gamma L. So magnitude of gamma L is k, so 1 minus k, so it is greater than 0 because k is less than 1, so 1 minus k should be greater than 0. Third one is what is the value of x max? X max is equal to 2n pi and theta gamma is pi into lambda divided by 4. That means odd multiple of lambda by 4. That means odd multiple of lambda by 4. And x min is 2n pi, 2n plus 1 pi plus theta gamma into lambda by 4. That means x max will be 2n lambda by 2, n plus 1 lambda by 2. So location of maxima minima is not changed, they are same. Location of maxima minima is not changed, they are same. So we can draw the graph of VSWR. What is the value of VSWR for this case? So we can draw the graph of VSWR. So Vmax is less than 2 Vf. Vmax is less than 2 Vf and Vmin is greater than 0. Vmin is greater than 0. So the graph will be shrink. Why it is shrink? You can see here. The Vmax is 2 Vf, Vmin is 0. So graph Vmin is going upward greater than 0, Vmax is 6 going downward less than 2 Vf. So graph will be shrink because it is greater than 0, it will be less than 2 Vf. So the graph will be shrink and graph is shrinked, so we can draw the graph. Like that. The graph will be like this only. So this is the graph for Vmax and Vmin. This is the graph for Vmax and Vmin. So here maxima at lambda by 4 maxima, at lambda by 2 minima, at lambda by 4 maxima, at lambda by 2 3 lambda by 4 maxima, and then after we have at lambda minima. At lambda it will be minima. So at 0 at load minima, at lambda by 4 maxima, at lambda by 2 minima, at lambda by 3 lambda by 4 maxima, at lambda minima. This is the value of x. So 0 0 minima, lambda by 4 maxima, lambda by 2 minima, lambda by 4 maxima. So 3 lambda by 4 maxima, lambda minima. Hello. So this is the point, and we have magnitude of V. This is the graph of V. This is Vmax and this is Vmin. So graph of Vmax and Vmin is like that. Next Next we have graph of current also. Next we have graph of current also. I will take graph of current also. So this is the graph of current. This is the graph of current. If voltage is minimum, current is maximum. If voltage is minimum, current is maximum. If current is minimum, voltage is maximum. So this is the graph for current. This is the graph for current. So this one is current I, and this one is V. This one is V. So we have voltage minima, current maximum. Yes, we have. So at this point, voltage minimum, current maximum, voltage maximum, current minimum, voltage minimum, current maximum, voltage maximum, current minimum, voltage minimum, current maximum. So you are getting like that. So this is the case of VSWR in ZL less than Z0. In ZL less than Z0. Yes, sir. Then we will go for next point. ZL is equal to Z0. What is the case for ZL less equal to Z0? ZL is equal to Z0, what will happen? So in case of ZL is equal to Z0, reflection coefficient will be 0. Reflection coefficient will be 0. So ZL minus Z0, ZL plus Z0, reflection coefficient will be 0. Yes, sir. So there is Vmax. Yes, sir. Vmax is magnitude of Vf only, and Vmin will be Vf only. So there is no maxima, no minima, neither maxima, neither minima, neither maxima nor minima. So neither maxima nor minima. So there is no location of maxima and minima, neither maxima nor minima. So no location of maxima and minima. So no standing wave. No standing wave. There is no standing wave. So the graph will be only a straight line. The graph will be only a straight line because there is no reflected wave. If it is matched, then there is no reflected wave. So the graph of voltage will be matched line. So this is the graph of voltage, and this is the graph of current. So we can say that the graph of voltage and graph of current will be same. There is no maxima, there is no minima. You can say like that. There is no maxima, there is no minima. So there is no standing wave. There is no standing wave. There is no standing wave. Next, fourth one is our ZL greater than Z0. In this case, what will happen? In this case, first of all, calculate gamma L. So I will take ZL is equal to 50 ohm and Z0 is equal to 25 ohm. Yes, sir. Then you can understand very easily. So ZL minus Z0, ZL plus Z0 is plus value. It will be 1 by 3. 50 minus 25, 50 plus 25. It will be 1 by 3. And 1 by 3, it will be positive value. So it will be positive value. So magnitude of gamma L is 1, K, which is less than 1. And the value of theta gamma is 0. Then we have Vmax. Vf into 1 plus K, that is less than 2 Vf. and V mean is equal to 1 minus k. That means 1 minus k means greater than 0. Third one is x max. X max is equal to 2n pi plus theta gamma into lambda divided by 4 pi and lambda by 2. Yes sir. And x min will be 2n plus 1 pi, theta gamma 0 and lambda divided by 4 pi. It will be odd multiple of lambda by 4. Odd multiple of lambda by 4. So what it means? It means the location of maxima will be 0 and lambda by 2 and lambda and 3 lambda by 2. So maxima will be from at load, and minima it will be lambda by 4, 3 lambda by 4, 5 lambda by 4, like that. So location of maxima minima is interchanged. Location of maxima minima is interchanged. So what will happen here? Here you can draw the diagram of VSWR. You can draw the diagram of VSWR easily. Yes sir. So VSWR Vmax should be less than 2 Vf. Vmax should be less than 2 Vf, and Vmin should be greater than 0. Vmin should be greater than 0. So this is Vmax, this is Vmin, and this one is our x. This one is our x. So Vmax should be greater than 0. Vmin should be less than 0. So greater than 0 to less than 2 Vf and greater than 0. So what will happen? Maxima minima. Maxima and minimum. Yes sir. So this is the graph for maxima minima. So maxima at lambda by 4 minima, then maxima at lambda by 4 minima. So like that there is the things. Yes sir. So there is a maximum point, there is a minimum point, there is a maximum point, and there is a minimum point. Yes sir. This is the point at maxima at load, maxima at load, minima at lambda by 4, maxima at lambda by 2, minima at 3 lambda by 4, and maxima at lambda. So this is the value. Then we can draw the for current also. We can draw the for current also. We can draw for the current also. So for current, this is the graph. For current, this is the graph. So this is the graph for current. Yes sir. So when voltage is maximum, current is minimum. When voltage is maximum, current is minimum. When voltage is maximum, current is minimum. And current voltage is minimum, current is maximum. Like that. So this is the graph for current. This is the graph for voltage. So voltage maximum, current minimum. Current maximum, voltage minimum. Voltage maximum, current minimum. Current maximum, voltage minimum. Voltage maximum, current minimum, like that. So this is the things for our which part? Thing for VSWR. This is the thing for our VSWR. Okay. So we can know the value of VSWR. Then there is another point, ZL is equal to infinite. ZL is equal to infinite. ZL is equal to infinite, what will happen? So gamma L will be equal to ZL minus Z0 divided by ZL plus Z0. So we cannot calculate the value of gamma L. So what we will do? I will take ZL common, 1 minus Z0 by ZL and 1 plus Z0 by ZL. So it will be 0 and this one is also 0. So it will be 1. So magnitude of gamma L is 1. Magnitude of gamma L is 1. Theta gamma is 0. Then we have second point. What point? Vmax. What is Vmax? Vf, 1 plus magnitude of gamma L. Magnitude of gamma L is 1. So Vf, 1 plus 1. That means 2 Vf. And Vmin is equal to Vf, 1 minus magnitude of gamma L. And Vf, 1 minus 1. It will be 0. So Vmax and Vmin we have calculated. Then third thing is we will calculate Xmax. Xmax is equal to 2n pi plus theta gamma into lambda divided by 4 pi. 2n pi and plus theta gamma is 0 into lambda divided by 4 pi. So it will be n lambda by 2. And for x min, what is the value? So x minima, it is 2n plus 1 pi. 2n plus 1 pi. Theta gamma is 0 into lambda divided by 4 pi. So it will be odd multiple of lambda divided by 4. That means it will be odd multiple of lambda by 4. Odd multiple of lambda by 4. And here what it will be? So x max is equal to 0, lambda by 2, lambda, 3 lambda by 2 and 2 lambda, like that. Then we have lambda by 4, 3 lambda by 4 and 5 lambda by 4 and like that. So we have got the location of maxima, we got the location of minima. So what we will do? We will draw the diagram. Tomorrow we will go for the summary point, and then day after tomorrow we will go for the question discussion. So one day for question discussion of VSWR and impedance. Okay. So this is the point here. Yes sir. So our voltage maximum is 2 Vf. So maxima and minima. So this is our maxima. Yes sir. Then after there is a minima, maxima, like that it will happen. Yes sir. Like that it will happen. So this one is 0, this one is lambda by 4, this one is lambda by 2, this one is 3 lambda by 4 and this one is lambda. Two here. This is the graph. Then we are drawing to do the graph of current. Then we are going to draw the graph of current. Graph of current will be a voltage is maximum, current is minimum. Current is maximum, voltage is minimum. Current is maximum, voltage is minimum. Like that. So this is the graph for voltage. This is the graph for voltage. This is the graph for current. So voltage and current we have drawn. So what we have done? We have done till now. First of all, we have done for ZL is equal to 0. ZL is equal to 0. What we have got? We have got V0, voltage minimum, current maximum. So like that draw will be there. Then after we have ZL less than Z0. So voltage minimum, current maximum. The graph will be drawn like this. Then after we have ZL is equal to Z0. There is no maximum minima. Then after we have the voltage location of maximum minima is interchange. Voltage is maximum, current is minimum at load. Then we have the last point. Voltage maxima, current minima is changed. Here first voltage maxima, then current minima. So this is the point which we have to remember. Tomorrow class will discuss this in a very elaborate way. So today is our end of class. That means today we will end up this VSWR. So we will end up this VSWR. Okay. Tomorrow we will have also VSWR. Same timing 5 PM to 6 PM. You can download Unity app. It is very beneficial for you. And thank you. You can join this good Telegram group, Sonu Sir PW. It is very useful. If you have any doubt, you can resolve it from here. Thank you very much. We will meet it again tomorrow 5 PM.